Hello and welcome to this session in Business Research Methodology. We are discussing Chapter 5, that is Sampling and Sampling Distributions. I'm your instructor Rajesh Durbala and I'm an assistant professor in Business Analytics and Research Methodology. So what's there in this session today? Let's take a brief glimpse of the entire thing. Now what are we going to discuss? That is, we'll be understanding the importance of sampling. First of all, we'll try to understand why do we go ahead with sampling. Can't we do away with sampling? So we'll be discussing all those stuff. Then differentiate between random and non-random sampling, and understand the concept of sampling and non-sampling errors. Then the next two parts, that is understand the concept of sampling distribution and the applications of central limit theorem, and subsequently understand sampling distribution of sample proportion. The last two objectives would be covered in a different video, which would be a sequel to this video. So primarily in this video we'll be focusing on the first three objectives, that is understand the importance of sampling, differentiate between random and non-random sampling, and understand the concept of sampling and non-sampling errors. Let's move ahead. What is sampling? Usually, a researcher generally takes a small portion of the population for study, which is referred to as a sample. The process of selecting a sample from the population is called sampling. Now, usually what happens is a researcher wants to study a phenomenon existing in the entire population. So for him, it becomes practically impossible to gather the parameters of the entire population. So to simplify things, the researcher takes a small portion of the population, okay, and tries to study the parameters, the characteristics and the features of that small portion of the population. And once that study is accomplished, he tries to map the parameters of the sample with the parameters of the population. So this entire process is called sampling. Now, why do we do sampling, or why is sampling is essential? That's quite simple. That is, sampling saves time. Rather than studying the entire population, if I do my study on a small portion of this population, that definitely saves a lot of time. Sampling also saves money. We quite often say time is money. So if I'm able to save time, I'm also saving money. Okay, but in literal sense as well, we can definitely save a lot of money if we go ahead with sampling. Then when the research process is destructive in nature, sampling minimizes the destruction. Now let us say if I have to test a bomb, would I drop the bomb on the entire population to see the effectiveness of the bomb? The destruction would be large scale. Rather than dropping the bomb on the population, I can drop that same bomb on a small deserted or maybe uninhabited island, or maybe an island where the population is quite small, in order to reduce the destruction. Okay, so sampling is important in that aspect as well. Then sampling broadens the scope of the study in light of scarcity of resources. All resources are scarce, and in order to optimize those scarce resources and to broaden the scope of the study, we can go ahead with sampling. Similarly, it has been noticed that sampling provides more accurate results as compared to census, because in sampling, non-sampling errors can be controlled more easily. There are a lot of non-sampling errors. For example, the way we analyze the data, while we report the data, while we are simply punching in the data, a lot of errors could occur. But when sampling is done, since it's a small size, such kind of errors could be minimized. And moreover, when I go ahead with census, what am I doing is I'm catering to the entire population, and when I'm doing the same study on the entire population, by the time I finish the entire study, a lot of changes occur in the population. And when such changes occur in the population, and when I publish my results, a lot of things could have changed. So the accuracy of census is quite obscure. Then In most cases, complete census is not possible, and hence sampling is the only option left. That's quite obvious, okay? Then these are the 5 steps in the sampling design process. The step 1, that is define your target population. Step 2, you must define your sampling frame. Step 3, appropriate sampling techniques must be selected. Step 4, sample size must be determined. Step 5, sampling process must be executed. So this entire flow is quite self-explanatory, but I would like to discuss each and every step in great detail. Step 1, you have to design the sampling process. In that, the first step should be you have to define your target population. So who should be your target population? So target population is the collection of objects which possesses the information required by the researcher and about which an inference is to be made. Now let us say if I want to make a research, or if I want to do a research on the mobile phone users in Delhi, okay? So if I want to make a study on the mobile phone users in the city of Delhi, so my target population can easily be defined as the mobile phone users in the city of Delhi. Okay. Similarly, the next step, that is sampling frame, must be determined. Now, when I am talking about the sampling frame, it becomes quite important that I have to understand what my sampling frame is. Now, sampling frame is a published list, a directory, a map, a data. Okay, it can simply be the Sensex also. Okay, any of such published results could become my sampling frame. Okay, if I read what is written on the slide, a researcher takes a sample from a population list, directory, map, city directory, or any other source used to represent the population. Likewise, I was giving you the example of the mobile phone users in the city of Delhi. If it is possible, I can simply, take the data from the cellular phone operators, or I can also, if possible, extract the data from the try. Okay, so that can become my sampling frame. Then my sampling design process, step 3, appropriate sampling techniques must be selected. Now, when I am selecting the appropriate sampling technique, I have to be careful to look into what kind of technique is required. Am I going for a non-probabilistic technique, or I am going for a probabilistic technique, or am I going for a replacement or a technique without replacement? So what is the technique that I need to follow? Okay, so whatever the research requirements are, or the objectives of your research are, you have to select an appropriate technique. Then step 4, sample size must be determined. What is the appropriate size? The researcher has to be very clear about that as well. Then sampling process must be executed. This is the final step where we go ahead with sampling. Okay, then random versus non-random sampling. Now, what do we understand by this? Random sampling, as also known as probabilistic sampling, and non-random sampling is again non-probabilistic sampling. In random sampling, the probability or the chance of every element in the population is the same. That is, each unit of the population has the same probability or chance of being selected as part of the sample. That is to say, if I pick a few students, I need to pick a few students in the class. I randomly put their roll numbers in a bowl and I pick 5 students randomly. That is, I can say every student had the equal opportunity or chance to get selected. Okay, so such kind of a selection becomes random sampling. And in case of non-random sampling, I'm using some other parameters, I'm using some other ways in which the samples could be selected. that could be my judgment, my familiarity, anything. Okay, so what is happening is every element doesn't have the equal opportunity to get selected. That is what is non-random sampling. Okay, so if you put this way, these are the various sampling techniques. One is random sampling methods, the other is non-random sampling methods. In random sampling, I have simple random sampling, stratified sampling, cluster sampling, systematic sampling, multi-stage sampling. Okay, and in non-random sampling, I have quota sampling, convenience sampling, judgment sampling, and snowball sampling. We'll discuss each method in detail. Let's move ahead. Simple random sampling, that is the same as random sampling, where each member of the population has an equal opportunity or chance or probability of getting included in the sample. Okay, and stratified sampling. Now what is happening is, understand this very carefully. From the population, we divide the population into various groups. Okay, the elements or members within each group are homogeneous, and one group is entirely different from the other group. Such groups are called strata. Okay, now then what does the researcher do is, the researcher uses simple random sampling methods to select the sample from each of the strata. Okay, now each group then becomes a stratum. Now in stratified random sampling, stratum should be relatively homogeneous and the strata should contrast with each other. That's what I told you in the beginning. That is, the elements within the strata should be homogeneous, whereas one strata should be entirely contrasting to that of the other strata. Okay, then what I'm talking about, you can see now. This is matriculate, this is one strata, this is graduate, this is another strata, this is postgraduate, this is another strata. Okay, now what you can see is, matriculate is entirely different from graduate, graduate is different from postgraduate. So there is heterogeneity among these three, but within the matriculate box there is homogeneity. Okay, within the graduate box there is homogeneity, and within postgraduate there is homogeneity. Okay, now what we try to do is, that's very important. When we pick samples from in this manner, that is in a stratified manner, the sample extracted from a population should have matriculates, graduates and postgraduates in the similar proportion as they exist in the population. This is very important. The proportion of matriculates, graduates and postgraduates, that is the proportion of each strata in the sample, should be the same as that in the original population. Okay, now cluster or area sampling. In cluster sampling, what we do is, we divide the population into various clusters. In this, what happens is, the elements within the cluster are heterogeneous, but one cluster is more or less homogeneous to the other cluster. So that's the basic difference between stratified sampling and cluster sampling. Okay, can you observe the difference? Here the clusters are homogeneous. In the previous stratified sampling, the clusters were heterogeneous among each other. Now in cluster sampling, the elements within each cluster are heterogeneous, whereas the elements within each strata in stratified sampling were homogeneous. Okay, now systematic or quasi-random sampling. Here what we do simply is, let us say for example, I have a population of 900 and I have to extract a sample of 30. So what I do is I calculate a k value. Okay, a k value can be simply a factor. Okay, now how we calculate is we take the entire population divided by the sample, then I get my k. In this case 900 divided by 30, I get 30. Okay, now if let us say I am waiting in a mall and I have to do some study on the buyers who are visiting the mall. So if I pick the first respondent to be the third respondent, then the next would be 3 plus the k value, that is 30, that is the second respondent would be the 33rd respondent. After 33rd, the next respondent would be 33rd plus another k, that is another 30 equals to 63rd. Okay, so this is what is systematic sampling. Now in this multi-stage sampling, as the name indicates, multi-stage sampling involves the selection of units in more than one stage. Okay, let us say at first stage I do the sampling from states, at the second stage I do it from districts, third stage I do it from cities, and on the fourth stage I do it from blocks. So this is what is multi-stage sampling. Okay, now non-random sampling. Non-random sampling, I have majorly around 4 types, that is quota sampling, convenience sampling, judgment sampling, and snowball sampling. Okay, we'll discuss one at a time. Quota sampling, in certain cases, let us say such as age or gender or income group or education level, are used as a strata. Okay, now stratified random sampling is based on the concept of randomly selecting units from the strata. However, the contrast is, in this case of quota sampling, a researcher uses non-random sampling methods to gather data from one stratum until the required quota fixed by the researcher is fulfilled. Okay, now I'll give you a practical example. What we were doing is we conducted a small research on the slums in Mumbai. Now the objective of the research is what are the housing requirements from the houses or from the slums of slum dwellers. So this project, the government wanted us to figure out what are the requirements or what do they expect from their homes. So they made it compulsory that the government ensured that the sample that we pick must minimum be comprised of 10% of children below the age of 10, and minimum number of female respondents should be 20%. Now can you imagine, now let us say I have a sample of, let us say 100, out of which the quota is fixed for the females, that is out of every 100, 20 should invariably be females and 10 should be kids below 10 years of age. So if I am not using any random sampling techniques for these 10 kids or these 20 women, I pick them based on my convenience maybe, or based on my familiarity maybe. So that becomes quota sampling. I keep on doing this till I achieve my specified quota of 10% and 20%. So that is what is quota sampling. Convenience sampling, obviously convenience sampling, let us say now I've been teaching in this region of Jalandhar. Now whenever we do any research, so what we do is most of our sample we pick from areas which are close to Jalandhar, and the reasons are quite obvious. The reason is obvious, that is we are doing a convenience sampling. It is convenient for us to pick sample from areas which are close to Jalandhar. Okay, so that is what we are doing, and the sampling technique that we are using is convenience sampling. Okay, then judgment sampling. Judgment sampling is we are picking a sample just based on our judgment. Now let us say if I need to do a study on the most luxurious or the richest people in Punjab. Now if this is the case, immediately what kind of places would come instantly to my mind? For me, the first thing that comes to my mind is, if I have to do such kind of a research, I need to go to Chandigarh. And I personally believe that the most or the richest people in Punjab reside in Chandigarh. That may factually not be true, but that's simply my judgment, that's my hunch. So my study will directly, I'll go to Chandigarh to do my study. That is based on my judgment. So the sample that I pick from Chandigarh would become a judgmental sample. Now, snowball sampling. Snowball sampling, in this, the survey is conducted with the help of respondents, and I take referrals from the respondents to increase my respondent base. I'll give you an example. We were doing a study on the impact of NRI investment in the rural development of Punjab. Now, how do we get hold of those NRIs? It's quite difficult. So what we started doing is, the moment we met any NRI, we started asking for referrals from them. So they gave us few email IDs, few phone numbers, and based on that we started contacting them. So when we started off, we hardly had around 30 or 40 connections, but we ended up conducting a research of more than 900 people. So this is how we created a snowball sample. Now, what are the sampling and non-sampling errors? Now, sampling errors occur when my sample is not a true representative of the population. That is to say, the parameters of my sample do not match the parameters of my population. Okay, so what could be the various errors that can occur due to what kind of reasons? Let us get into the reasons why we encounter sampling errors. First and foremost, faulty selection of the sample. I selected a wrong sample altogether. Okay, so that could be one of the reasons. Second is, sometimes due to the difficulty in selection a particular sampling unit, researcher tries to substitute that sampling unit with another sampling unit which is easy to be surveyed. Quite obvious. I was giving you an example of the research that we did, in which the NRI population had to be studied and how their investment is helping in the development of rural areas of Punjab. The first thought that we came across was, why not study the families whose members live abroad? So that could give us some kind of tangible results. But we thought against it. But if we had done it, that would have given us a sampling error. Okay, and sometimes the researcher demarcates the sampling units wrongly and hence provide scope for committing sampling error. Now, if my demarcation of the sampling units, if that is wrong, that also can lead to serious sampling errors. And what are non-sampling errors? This is quite obvious. These are quite simple as well. Faulty designing and planning of survey. If I design and plan my survey in a faulty way, that can be a serious problem. Okay, I have response and non-response errors. Okay, if the respondent responds and gives me a wrong response, that also is a problem. And sometimes the respondent is not willing to respond, that also is a problem. Okay, then errors in coverage. If my coverage also has some problems, if I had to cover some serious areas and I miss out on these areas, then the entire responses or the results of the survey could be biased and skewed. And if I'm compiling and publishing and there are some clerical errors, that also could be a serious reason or source for non-sampling errors. Okay, and what is sampling distribution? Now, in a representation of sample statistics, values obtained from every conceivable sample of a certain size chosen from a population by using a specific sampling procedure, as long with the relative frequency of those statistics values. Now, what is all this? This is quite simple. Okay, I'll give you a simplified version of understanding this. Now, I have a huge sample, I have a huge population from which I extract n number of samples, okay? And each sample will have its parameter, that is, let us say mean. I have n means from n samples, okay? And if I make a sample from all the n means, those means can also become a sample, okay? Now, that sample which is created from the means of all the various samples can become a sampling distribution. Are you understanding what I'm trying to tell you? If I extract n different, so let us make this simple. If I have a population of 100, I extract 10 different samples of 5 each, okay? So what am I doing is I have 10 different samples of 5 each, and I have a mean in all these 10 samples. So if I extract one mean each from all the 10 different samples, and if I put together all the 10 means from each sample, I have another sample which has the means of all these samples. That sample created from the means is nothing but a sampling distribution. I hope that's clear. Okay. Now, this is a practice question for you, which I will prefer to discuss in the CLT part, that is central limit theorem part. So that will be in the next video. Once we reach the next video, I'll discuss this question then. So you can get in touch with me. You can follow me on LinkedIn, Facebook, Twitter. You can write directly to me at rajeshdourbala@gmail.com. That was nice interacting with you. Thank you for your attention. Hope to see you soon.